Welcome to this explainer. If you've been feeling a mix of curiosity and, let's be real, maybe a little overwhelm about the massive hype surrounding generative AI lately, well, you are in exactly the right place. Our goal today is super simple. We're going to break down exactly what generative AI is, how it actually works under the surface, and where this whole technology is heading next. And we're going to do it all by looking directly at the facts, entirely jargon-free. Okay, let's dive into this. To really understand what makes generative AI special, we first kind of need to compare it to what came before. For years, traditional AI was mostly used to analyze or classify existing data. You'd ask it, hey, is this email spam? And it would sort it for you. Generative AI, however, completely flips the script. It's a probabilistic subset of AI, and its main purpose is to produce entirely new content. So instead of sorting an email, you literally tell it, write me an email, and it generates original text right there on the spot. And it's doing this across text, images, audio, and even complex computer code.
Now, I want to clear up a massive misconception right off the bat. Generative AI is not a search engine doing some quick database lookup and pasting an answer it found on the internet. Actually, it's a lot more like a jazz musician improvising. These models are trained on massive data sets to learn statistical patterns. So when you give them a prompt, they synthesize completely fresh outputs based on those learned patterns. The output might resemble the training data, sure, but it's never an exact copy. Every single performance is newly generated in that exact moment. So here is our roadmap for today. 1. Meet generative AI. 2. Peering under the hood. 3. Real-world applications. 4. Risks and limitations. And 5. The agentic future. Section 1. Meet generative AI, the breakthrough era. While artificial intelligence as a broader field has been around for decades, what's absolutely staggering about this breakthrough era is the compression of time. We're talking about a whole decade of theoretical progress squeezed into literally just a few short years. In 2017, the fundamental transformer architecture was introduced. Fast forward to 2020, and GPT-3 starts showing us what large language models can actually do. Then 2021 brought us DALL-E for images, and of course, late 2022 changed basically everything when Stable Diffusion and ChatGPT disrupted the market, putting this immense power directly into the hands of hundreds of millions of everyday users.
Section 2. Peering under the hood. How it actually works.
It can honestly feel like magic when a computer writes a heartfelt poem or draws a beautiful picture, but underneath it all, it's really just math. And it all starts with a token. Large language models, or LLMs, do not read words or characters the way you and I do. They process tokens, which are essentially word fragments. So a word like unbelievable might actually be broken into 3 separate tokens. At its core, an LLM is literally just trying to predict the next token based on probability. It's like a giant game of fill in the blank. If I say the capital of France is blank, the model assigns a super high probability to the token Paris. And it manages to stay on track using something called an attention mechanism to look across all the previous tokens, maintaining coherence even over really long passages of text. So because this entire process is probabilistic and not deterministic, you can actually control its behavior. That's exactly what the temperature setting does. If you set the temperature low, the model takes the most obvious predictable path, which is fantastic for factual coding or strict data analysis. But if you crank that temperature high, you introduce randomness. The model starts picking less obvious tokens, leading to highly creative and surprising outputs. That's exactly why you can give a model the exact same prompt twice and get completely different answers back.
But here's the catch. A model is only as good as its memory, which we call the context window. Think of this as the model's working memory for your current active conversation. Modern models like Claude have a context window of 200,000 tokens. To put that into perspective, that's roughly 500 pages of a book that it can hold in its brain all at once. But it's absolutely crucial to remember that anything outside of this specific window is entirely invisible to the model during that generation. It just doesn't exist to it.
All right, let's shift gears from text to images for a second. Image generators, like DALL-E and Stable Diffusion, use what's called a diffusion model, and it works a bit like developing a photograph in an old-school darkroom. It actually starts with a canvas of pure random TV static or noise. Step 2, it uses its learned patterns to predict a slightly less noisy version of whatever image you asked for. And step 3, it just repeats this process over and over, gradually denoising the image until a crisp, highly detailed picture magically reveals itself. And this brilliantly illustrates another popular visual AI method, GANs, or Generative Adversarial Networks. Imagine an art forger and a detective. The generator is the forger, desperately trying to create a fake image that looks real. The discriminator is the detective, analyzing the image to see if it's a fake, and they compete against each other thousands of times a second. The forger gets better at faking, the detective gets better at catching. This intense adversarial loop is exactly what produces incredibly realistic synthetic data, style transfers, and yes, deepfakes. Section 3. Real-world applications. Generative AI in action.
Because modern models are getting increasingly multimodal, meaning the boundaries between text, images, and audio are completely dissolving, they're transforming industries across the board. Take software development. AI coding assistants like GitHub Copilot are already showing a 55% increase in coding speed. In healthcare, Google's AlphaFold used generative capabilities to predict the structure of nearly all known proteins, effectively solving a 50-year-old scientific mystery. In education, platforms like Khan Academy are rolling out personalized AI tutors that adapt on the fly to a student's individual learning level. And over in the creative industries, tools like Suno are generating full studio-quality songs. We're talking lyrics, melodies, and instrumentation just from a basic text prompt. It's truly everywhere.
However, seeing all this raw power naturally leads us to a pretty critical question. What happens when the model is incredibly confident, but completely, entirely wrong?
Which brings us to Section 4, Risks and Limitations.
It is absolutely vital that we look at this technology neutrally to understand its core hurdles. First up, hallucinations. Because these models lack an internal fact checker, they can generate fluent, highly authoritative sounding statements that are entirely false, sometimes even fabricating academic citations out of thin air. They literally don't know what they don't know. Second, the sheer ease of generating realistic deepfakes presents massive challenges for global misinformation and personal reputation. Third, there's bias. If a model is trained on historical data that contains human biases, it's naturally going to learn and amplify those very prejudices. And finally, intellectual property. These models were trained on billions of images, books, and articles, often without explicit consent or compensation, resulting in massive ongoing legal battles that are absolutely going to shape the future of copyright law.
And of course, there's the reality of economic disruption. Roles that rely heavily on routine tasks, things like basic copywriting, entry-level coding, standard data entry, and frontline customer support, are facing very significant automation pressure. Now, while economists heavily debate the exact speed and scale of this job displacement, the fact that major workflow shifts are happening right now is a certainty we all have to navigate.
Finally, Section 5, the agentic future. Where we go from here.
Between 2025 and 2030, we're expecting a massive paradigm shift. We are moving from AI just answering to actually doing. This is the difference between AI that talks and AI that acts. In the current state, you ask the AI to write a trip itinerary, it prints out a nice list, and then you have to go to the airline website to actually buy the tickets. But with agentic AI, systems like Claude's Cowork or OpenAI's Operator are being built to act as autonomous agents. You just tell the agent, book my flights, hotel, and restaurant, and the AI itself opens a web browser, navigates the sites, inputs your data, and completes the entire multi-step task for you. So here's your technological roadmap for the next 3 years. First up, reasoning models. Rather than just spitting out the first predicted token, models like OpenAI's O3 actually pause, plan a strategy, and self-correct their own logic before giving you an answer. Second, watch for those multimodal agents we just talked about. AI that can literally see your computer screen and click around inside software just like a human operator would. And third, keep an eye out for powerful on-device models that run entirely locally on your phone or laptop. This gives you amazing AI capabilities completely privately without ever needing to ping the cloud. Which leaves us with this honest one-sentence summary to close on. Generative AI is the first technology in history that produces outputs we cannot fully distinguish from those created by human intelligence. We are watching a fundamental shift in how humans interact with machines, and we are only at the very beginning of understanding what that truly means for our society. So as you look at these tools and understand the mechanics beneath them, how are you going to use it?